Hello my friends, welcome back and mostly welcome to part 4, making the predictions and evaluating the model. And at the end of the previous tutorial, I actually asked you to do a little homework, which is right here, and which consisted of using your ANN model to predict if the customer with the following informations will leave yes or no the bank. So I hope you did well. You actually had all the tools to do it, and that's something we did before in part 3 classification. So I'm sure you smashed this. Let's see about that. Let's implement the solution together. Alright, so I left this code cell here to enter the solution, but this is just a comment, so let's just remove it. And now, how do we complete successfully that homework? Well, of course, we need to get first our ANN model, from which we're going to call a new method, different than the add method or the fit method. Right now, of course, we need to call the predict method, right? Absolutely no trap. We call this predict method to predict if yes or no the customer with the following informations will leave the bank. All right, and now since this is a method, I'm going to add some parentheses here. Let me actually scroll down, in case you're uncomfortable with the border at the bottom. All right, so predict, then, okay, so you have all the information of the predict method, but we know exactly what to predict. This is given in the instructions of the homework. We have to enter these informations. But there are a few things to pay attention to, and there are actually 3 things. That's why I really wanted to give you this homework, because I wanted to see if you could pay attention to 3 important things to include inside that predict method. Let's start with the most essential one, which is the double pair of square brackets, right? It's very important to remember that any input of the predict method must be a 2D array, whether it is the test set, to predict an ensemble of outcomes for an ensemble of observations, or whether it is a single prediction. Well, anything has to be in a double pair of square brackets, which therefore makes a 2D array. Basically, the format expected by the predict method is always a 2D array. Okay, so that was the first thing. Then, inside this 2D array, we're going to enter, well, the different informations here. And that leads me to mention the second important thing which you had to pay attention to, which is about that variable here, geography, France. According to you, do we have to enter, as you know, this first information here for the geography variable? Do we have to enter the string France, or do we have to enter something else? Well, of course, we have to enter something else, and that something else are the values of the dummy variables. Right, that's the second thing you had to do correctly, and therefore now we need to check what was the encoding for France. Well, remember, if we have a look at our matrix of features X, right above, in part 1 data preprocessing. So this is the matrix of features X, the whole matrix containing all the customers. So in order to know what France corresponds to, in terms of encoding, we just have to have a look at the first observation before one-hot encoding was applied, because indeed that first observation corresponds to France. And so now we just need to compare France here to the one-hot encoding resulting from what we did here. And well, we can see that the first row here contains 1, 0, 0 as the values of the dummy variables, and therefore France was encoded indeed into 1, 0, 0. So the dummy variable values for the France country in the geography variable is indeed 1, 0, 0. And that's exactly what we have to enter here as the first parameter. So let's do this. Let's enter 1, 0, 0. And there we go. Basically, that enters that first value of the first parameter, geography. All right, and then all the rest is easy. For the credit score, we will enter indeed 600. Then let's see the gender, male. So remember, male was encoded as 1 and female was encoded as 0. So here, in order to enter the male gender, we need to enter 1. All right, then 40 years old. Very simply, we enter 40. Then tenure, 3 years. We enter 3 here. Then balance $60,000. So we enter 60,000. Then let's see, number of products 2. So 2. Then, does this customer have a credit card? Yes. So 1, because 1 corresponds to yes and 0 corresponds to no. Is this customer an active member? Yes. So 1 again. And estimated salary, finally, $50,000. So our last parameter value here is $50,000. Okay? Yes, all good. Excellent. And now I have a question for you. Do you think we're done with this prediction, using the predict method with all these informations? And the answer to that is no. And that leads me to the third thing you had to pay attention to, which is the fact that, remember, the predict method should be called on the observations onto which the same scaling was applied as in the training. And since we trained our artificial neural network with the scaled values, the scaled values of the features, well, the predict method has to be called onto these observations to which the same scaling was applied. And that was the third thing you must have not forgotten, which is the fact that you have to apply your SC object here to scale that single observation. Right? That's super important. Make sure to pay attention to this. Check if some scaling was applied during the training. And yes, it is the case here. And anyway, it is always the case for neural networks. And therefore, in the predict method, well, we need to scale that single observation. And the way to do this is, of course, by calling our SC object. Yes, this one, from which we're going to call, be careful, not the fit transform, because the fit transform is used to, remember, get the mean and the standard deviation of the values in the training set in order to fit your scalar to the training set. But then for the test set, we only need to call the transform method, because if we fitted again the scalar, well, that would cause some information leakage. I explained this in part 1 data preprocessing. Check it out again if you need, but remember that on the test set or on new observations on which you deploy your model in production, you can only apply the transform method. And that's what we're going to call here transform, there we go, which has to take as input the whole observation in these double pair of square brackets. All right? Perfect. Good, good, good. So basically that's it. Now we can run that cell. Now we can get our prediction. But remember that when compiling our ANN to, an optimizer, a loss function, and a metrics, remember that in the output of our artificial neural network, we chose a sigmoid activation function, which therefore will return this prediction in the form of a probability, meaning that instead of getting the final outcome 1 or 0, whether the customer left or stayed in the bank, well, we're going to get the probability that this customer leaves the bank. But you'll see it will be very easy to get the final prediction 1 or 0. But first, let me show you what we get with this prediction. So we're going to put all this into a print, right? All this into a third pair of parentheses. Now let me play that cell, and we get that the predicted probability that this customer leaves the bank is 0.04, 0.038, 0.04. And therefore, it is predicted that this customer has a very low chance to leave the bank. And if you don't want the outcome in the form of a probability, well, the trick to convert this into the final prediction is very easy. You just need to add here, just before the last parenthesis, the larger symbol and then 0.5. Why is that? That's because, all this, ANN predict, then SC transform, then all the informations of the customers up to here returns exactly the predicted probability. And here we choose a threshold of 0.5 to say that if that predicted probability is larger than 0.5, well, we will consider the final result to be 1, right? Because the predicted probability that the outcome is 1 is larger than 0.5, meaning that there is more than 50% chance that the predicted outcome is 1. So we'll consider it to be 1. And however, if the predicted probability that the customer leaves the bank is below 0.5, well, we will consider it to be 0. Of course, you can choose a different value of the threshold, especially when you have critical outcome, for a critical decision. And in that case, you can, for example, increase the threshold. But here, let's just pick the default value, 0.5. This totally makes sense for our case study. And therefore, now if we re-execute this cell, we will of course get the final outcome, which will be of course 0 or false. False, we should not say goodbye to that customer, or false, the customer won't leave the bank. In other words, it will stay in the bank. So good, Good news for the bank, but anyway, I just wanted to show you how to use your artificial neural network to predict the outcome of a single observation, meaning a single customer. Remember the three things. First, you have to enter your informations in a 2D array with a double pair of square brackets. Then you need to be careful with the dummy variable values here instead of entering the string input for that categorical variable. And then the third thing, remember to apply the scaling from your SC object because your artificial neural network was trained with scaled values. Okay, great. All right, so now let's finish this implementation in a flashlight. You know, the last two cells we have, by the way, I gave you some important notes here so that you can remember. That's basically what I explained. But anyway, now we have two cells to go. The first one is, that cell which you know very well, where we predict the test set results by displaying next to each other the vector of predictions y_pred and the vector of real results y_test. So we're going to do this the most efficiently by juggling with our toolkit. And finally, same, we will make the confusion matrix to get the final accuracy on the test set. All right, let's do this efficiently. So we're going to go back into our machine learning A to Z folder, to juggle with our toolkit. So I'm clicking this shortcut here to get the original base of the folder, machine learning A to Z. Then I'm just going to go, into part 3 classification to take any model. Let's take, logistic regression, for example, then Python. Then I can open this implementation, which contains indeed a lot of tools, which we can do with classification, as we are doing right now with our ANN. And now I'm just going to scroll down and get, the final cells, which will do exactly what we're about to do now with our ANN. First, to display next to each other the vector of predictions and the vector of real results. So let's get that cell. Let's paste that inside a new code cell right here. But remember that now, since our classifier, which is no longer called classifier, but ANN, returns the predictions in the form of probabilities, well, we just have to do a little something here, which is to, of course, convert our predicted probabilities, which are in y_pred, into predicted binary outcomes 0 or 1. And the trick to do that is exactly the same as the trick we used here. It is, of course, to update y_pred the following way by setting it equal to, well, the Boolean result of whether y_pred, the predicted probability, is larger than 0.5. So that if y_pred is between 0 and 0.5, then this new y_pred will become 0 because this won't be true. And if y_pred is larger than 0.5, then this will be true, and therefore y_pred will be equal to 1. All right, and we'll get therefore the final predicted binary outcomes 0 or 1. And then the rest is the same. All this is good. So let's play that cell and we'll get indeed displayed next to each other. First on the left the vector of predictions, y_pred, and on the right the vector of real results, y_test. And now we don't have all the results displayed. That's because we have a lot of observations. But we can already see that the predictions look pretty good. That first customer of the test set, be careful, that's all the customers of the test set. Well, that first customer in reality stayed in the bank and was predicted indeed to stay in the bank. However, that second customer actually left in reality the bank, but was predicted not to. It was predicted to stay in the bank. Then the third customer stayed in reality in the bank and was predicted to stay in the bank as well. And then for these three last customers of the test set, well, they in reality stayed in the bank and were predicted to stay indeed in the bank. So the results look really good, but the real way to check this is with our confusion matrix. And therefore here in our logistic regression tool, code template, well, we just have to scroll down a little bit more to find the code for the confusion matrix and also the computation of the accuracy. So let's just get this. Then let's just copy that into a new code cell. Let's just paste it. And now, are you ready to get the final accuracy of your very first artificial neural network on the test set, right? Meaning on new customers on which the model wasn't trained. Well, let's check this out right now. Let's play that cell. And very good. We get an accuracy over 86%. That's really good because it means that out of 100 customers, well, 86 were predicted correctly to either stay in or leave the bank. And we can actually see here the details of these predictions. we had 1,520 correct predictions that the customer stays in the bank. Then we had 203 correct predictions that the customer leaves the bank. Then we have 75 incorrect predictions that the customer leaves the bank, and 202 incorrect predictions that the customer stays in the bank. So anyway, that looks pretty good. The accuracy of 86% is a very decent accuracy. Of course, I challenge you to beat that, to at least get 1 or 2 extra % of accuracy. But I actually experimented it myself, and it will be pretty hard to beat this. So don't waste too much time on this. Plus, I rather encourage you to, check out this free course that we have on artificial neural network for regression, because I'd really like you to do anything you want with artificial neural networks, whether it is to do classification for either a binary outcome or a non-binary outcome, or regression, right? With this course plus the other free course, you'll know how to do anything with artificial neural networks. So that's rather my recommendation. And now, of course, I want to say a final congratulations. You completed a pretty advanced branch of machine learning, so you can really be proud of your progress. And if you're not too overwhelmed, well, it's time to reach an even higher level with convolutional neural networks. So as soon as you feel ready for it, well, join us, Kirill and I, in the next section to tackle convolutional neural networks. And until then, enjoy machine learning.